Okay, so today we are doing inscribed angles, and if you look at your packet, we should be on the bottom of page 13. Now, we've talked about a lot of other stuff, but remember from the definition that an inscribed angle is an angle inside a circle that has the vertex on the side of the circle, not on the inside of the circle. That makes these two pieces chords. Now, looking at an inscribed angle, there are a bunch of different things we can look at with them. One of the things that is created is called an intercepted arc. That intercepted arc is the arc that is formed basically when there is an inscribed angle. So this point here and this point here are the end of the two chords, but arc AC would be that intercepted arc. It is the arc that is at the outside of the inscribed angle is the easiest way to describe it. Now, inscribed angles and intercepted arcs have a really close relationship. This is your inscribed angle. The arc that goes with it, that would be arc AC, is always 2 times whatever the inscribed angle is. So if the inscribed angle is 10, the arc is 20. It's always twice. I can also say that the other way, that if you have the intercepted arc, the inscribed angle is half of it. Okay, then there's some other stuff that we have to talk about that are with inscribed angles. The next one is called an intercepted diameter. That basically just means that if there is an inscribed angle that has part of the diameter on it, the diameter here would be BC, then there is a right angle formed opposite of that. So that means BAC here would be 90 degrees. Okay, then turning to page 14. At the top of page 14, this is the last kind of case we can have. That is called an overlapping arc. Overlapping arcs have 2 inscribed angles. If they intercept the same arc, so here AD, either ACD or ABD could go with that arc. That means they're congruent. So that means this angle here is going to be the same as that angle there. Okay, so let's start. This first one is an inscribed angle. I gave those 2 words. I'm just going to call that IA. Now, if this angle is 47, this arc has to be 2 times the angle. So I'm going to say 2 times 47. And that gives me 94 here. Now, because I have a semicircle, I'm going to do 180 minus 94, and that makes arc BC, the one I'm looking for, equal to 86. Ooh, my pen. 86 degrees. So there's lots of different ways we can work with these that are kind of like working forwards or multiple steps or working backwards. So the next one is going to be a working backwards. It wants me to find the angle. In order to do that, I have to know what this major arc, J and L, is. So to figure that out, I'm going to do 360 minus 53 minus 65. That means this major arc here is 242. Now remember, the arc is double, so if I need to find the angle, I'm going to do 242 divided by 2. That makes that angle measure 121 degrees. Okay, my last one is an overlapping arc. So that just means this 139 is going to have the same properties that, or is going to make these two angles, sorry, have the same properties. So they will be the same. So in order to figure it out, I have to look at what I'm looking at first. So first I need RST, and then I need RUT. So in order to figure out RST, I've got to figure out, let me mark it first. In order to figure out RST, that's this one, I need to figure out this angle here. I mean this arc here, RT. In order to do that, I'm going to do 360 minus 139 minus 64 minus 75. That is just all of the arcs along the side that I have left. That gives me 82 degrees. Now remember, overlapping arcs are part of inscribed angles, and if they are part of inscribed angles, that means this arc is double what this purple angle is. So that makes that angle 41 degrees. I got that by doing 82 divided by 2. And remember, these two angles have to be the same because they're sharing that arc. So that means RUT is also 41 degrees. Okay, moving to the next. Here I've got another inscribed angle. Remember, this piece here is half of this. So in order to solve it, I'm going to say 158 divided by 2. 158 divided by 2 gives me 79. So that means that angle has to be equal to 79. Now I can solve for x by adding 9 to both sides. That gives me 88 is equal to 8x. When I divide both sides by 8, that gives me x is 11. Okay, looking at number 5, this is an intercepting diameter. So remember, across from where your diameter is, that angle is 90 degrees. Lucky for us, that's the angle it's asking us to find. So that means this whole equation is equal to 90. Do my 2 steps, add 1, and then divide by what's in front of x. And that leaves us with an x value of 7. Now, doing the intercepting diameters are not always going to be so straightforward. Like number 6. Number 6, I'm still solving for x, but I don't know what angle S is. I need angle S because that is across from this arc. I know angle U is 90. I've got 2 of the 3 angles, so that means I'm going to subtract from 180. Zoom in a little bit, make this a little easier to see. There we go. Okay, so 180 minus 90 minus 43 leaves me Why is my brain not working? What does that leave me with? $47. Now my brain's with it. That means this angle is 47. Now I'm going to finish solving similar to how I solved number 4. And the reason that is because this arc is double what my angle is. So I'm going to say 47 times 2. 47 times 2 gives me 94. And that is what that arc would have to be equal to, so now I can set it up and solve. If I add 14 to both sides, that leaves me with 108. 108 divided by 9 leaves me with an x value of 12. So this one had a few more steps, but overall I don't think it's too bad. Next I have a inscribed angle. Now this one's similar to number 6. I have a few steps to do. So I need to figure out what this arc is before I can do anything. In order to find that, I'm going to do 360 minus 162 minus 92. That gives me 106. So that means this arc is 106. Remember, the arc is double what the angle is. So to figure out how the angle measure so I can solve it, that's 106 divided by 2. That gives me 53. Now, 7x minus 10, I know, is equal to 53. Add 10 to both sides. Divide by 7. Gives you an x value of 9. Okay, so now I've got 3 more, and these are the more complex problems. So looking at number 8 on the bottom of page 14, it's given me a few pieces of information. It tells me angle FGH, that's this angle here, is 6x plus 21. And it also tells me arc FJH, that's this arc here, is 17x minus 28. And it wants me to find the measure in numbers of that arc, the purple one. Now in order to do that, first I always have to solve for x. And this one is a little more complex because remember this angle measure is 2 times what the arc is. So 2 times what the angle is gives me the arc. Because I have parentheses, I've got to distribute that 2 through both things. That gives me 12x plus 42. Then I've got to move stuff over. Unfortunately, my bigger x value is on this side, so I'm going to move my letters to that side. And then I'm going to get my constants on the other side. That leaves me with 70 is equal to 5x. To find x, I'm going to divide both sides by 5. That makes me have an x value of 14. Now I need to find FGH. Well, I've got FGH already. I just have to substitute that 14 in. So 17 times 14 minus 28. That gives me a value of 210 degrees. Flipping over to the next page, on number 9 on the top of page 15, I'm going to label what it gives me again. I've got ABD, that's this angle here. That is 6x plus 26. And then I've got ACD, that is this angle here, is 13x minus 9. It wants me to be able to find the arc. Well, lucky for us, in overlapping arcs, which is what this problem is, these 2 angles open to the same arc, so that means those 2 angles have to be the same. So I'm just going to set them equal, and I'm going to solve for x. I'm going to move my 6x over, add 9 to both sides, that gives me 7x is equal to 35. Dividing both sides by 7, that gives me an x value of 5. Now I'm not done because I need to find AD. So in order to do that, I'm going to take this x value and I'm going to plug it into one of the angles. So we're going to use the 6x plus 26. That gives me an angle of 56. Remember, if the angle is 56, the arc is doubled that. So I'm going to double 56, so times 2. And that gives me an arc measure of 112 degrees. That is my final answer. Okay, now I've got one more. And that is this one that is looking at an intercepting diameter. This intercepting diameter tells me the measure of angle KJL, that is this one here, is equal to 3x plus 2. It also tells me that KLJ here is 7x minus 32. And I know from previous knowledge, learning intercepting diameters, that this angle here is 90 degrees. Now, lucky for us, we know how to figure out anything in a triangle. I almost said a circle. Anything in a triangle already because it adds up to 180. I'm going to start with that 90 degrees so I do not forget it. And then I'm going to add those two expressions to it. Because it's a triangle, I know it has to equal 180. I'm going to simplify by combining like terms. Then I'm going to solve for x. You should get, oops, I can't add. You should get a value of x to be 12. 180 minus 60 is 120, not 130. Caught my mistake that time. Okay, so now looking at what it gives me, I've got x, and I want KL, arc KL. That is here. So in order to find that, I'm going to look across from it to the angle. That would be angle KJL, and I'm going to plug x into that expression. That expression was 3x plus 2. So that would be 3 times 12 plus 2. That would give me 38. Now that means that angle is 38, and in order to find the arc, I'm going to multiply that 38 times 2. 38 times 2 gives me 76, so that makes that arc 76 degrees. If you've got any questions, please reach out with them. Good luck.